Welcome back to Frequency Online Math. So we'll be talking about geometric progression. So what is this geometric progression telling us about? So consider an experiment denoted as A, which results in two possible outcomes, success and failure. Geometric distribution is repeated until a successful outcome occurs. So you know that you are seeing that this geometric progression is um, another way of saying, will I say, binomial distribution, because geometric distribution possesses some characteristics of binomial distribution because we do the trial nth time. It's not only one. We do it until we obtain what success. So um, geometric progression is repeated until a successful outcome occurs. Success occurs on the nth trial. So until success occurs on the nth trial. So it's success occurs on the nth trial means if you try it the first time, you do not get success, you continue, you continue, you continue. So that's geometric. The reason I say that geometric progression seems to have something related to binomial is because of the n trial, the number of trial. So it tells the probability of when the success is likely to occur. So condition for geometric progression, you see what I'm telling you. The condition for geometric progression are almost the same thing with that of binomial distribution. Why am I saying progression? Sorry. Each trial has only two outcomes, the same with binomial, that success or what failure. So each outcome is independent of one another. The same thing. Each outcome is what independent of one another. So probability of success is same for each trial. The same thing, the same property with even from here to number one is the same with binomial. The experiment continues until a success occurs. So this one is just not the same with binomial. So the experiment continues until what a success occurs. For example, if you flip your coin, you have coin, you have a head and a tail, and you want to get a head, and you do not get a head in the first flip, second flip, you do not get a head, third flip, you continue till you get what? A head. So we are going to write the formula for this geometric distribution. So this is our formula. P of x is equals to small letter x, which is equals to what? Q to the power of x minus 1, then times our p, where q is the failure, right? Probability of failure, and p is the probability of what? Success. Then our x is the number of n successful trial. Then our mean, that's expectation of x, is 1 over what? Success. So our variance, which is equals to 1 minus success, then over success what squared. Then our standard deviation sigma. You know, you can denote this variance as sigma squared, right? So sigma will be square root of 1 minus p over p squared. I want to tell you something. Some textbook will still write this formula as what? 1 minus p to the power of what? X minus 1 times p. They are still the same thing. You know that q is what? 1 minus p, right? So these are formula. So if we reduce it, if we solve it further, we are going to still have 1 minus p all over p. Because this one, okay, let me write it like this way, so that this will cancel this. We have square root of 1 minus p over p. So our standard deviation formula is what? Square root of 1 minus p over p. So that's it. In our subsequent videos, we'll be solving examples on this geometric progression. So this geometric progression is very simple. Just flipping your coin or your die until you get a successful event, the one you call success. Maybe you say you're going to get 6. Okay, this thing reminds me of when we were still small. This geometric, somebody will be doing something self, you don't even know what he's doing. When we are small, when we are playing Ludo game, you know that Ludo game is like this. Everybody have its own house. Everybody have its own house. Everybody have its own house. Like this. So you have a die. You have two die like this. Six-sided faces. So the rule for that Ludo is whenever you throw your toes, whenever you throw your die, are you there? Whenever you throw it, if you get, these are your this thing seeds. Each person have four. Each person have four. So if you throw the first this thing, if you do not get a six, that means you have failed. You give another person. Maybe this person started. He threw the thing. He got one and two. Two independent. You know that the seeds are independent of themselves. You get the outcome of this one does not affect the outcome of the other one. So this one with three, you get one and two here. One and two here. They will tell him that he will not get six, that he will not come out. This person will throw, and maybe this person will throw and get sick. We used to call it sicky. You get a six. Now he's qualified to do what? To come out first time. So this person will still throw again. If he will not get six, he will not come out. So now I get the what we use that time is this thing, geometric distribution. Wow, education is good. Thank you for watching and God bless you. Bye bye.